This is S. Lakshmanachari, working as Assistant Professor in Department of Cyber Security, Institute of Aeronautical Engineering, Hyderabad. In this lecture, we are going to discuss the characteristics of multiprocessors. So, multiprocess means the computer system which having two or more CPUs. That is called multiprocessor. So, in most computer systems are single process system. That is, they only have one processor. So that are called single processor system. That means the system which is having only a single processor, that is called single processor system. However, the multiprocessor or parallel systems are increasing in importance nowadays. So nowadays there is a rapid increases the usage of the multiprocessor systems because their speed is more. So that's why everyone is interested to use the multiprocessor system. So these systems have multiple processors. So multiprocessor, that means multiple, that means more than two processor, more than one processor, two or more. So these systems have multiple processors working in parallel. So that they can share the some common resources like the computer's clock, memory, and their buses and their peripheral devices. So all these resources are shared by all these multiple processors, so that they can work independently or concurrently, so that their access time will be reduced and the computer speed will be improved. So if you look into the architecture, multiprocessor architecture, so here you can see the multiple CPUs. So CPU 1, CPU 2, CPU 3 and CPU n. And so in this way we can connect any number of CPUs. And all these CPUs are sharing a common clock, because every CPU it requires a clock, every processor, because without the clock the CPU or processor will not work. So that's why every processor it requires a clock. So clock is nothing but it is a square wave. It is nothing but it is a so on and off. So that is a clock. So clock is required in order to operate every processor. So all these different processors, they are sharing a common clock and common memory and common buses and peripheral devices. So all these resources are shared by all these different multiple processors. So see, suppose if in multiprocessor systems, all these CPUs, they are communicating with each other through the common memory. So this is a common memory. Suppose if the first CPU 1 wants to communicate with the CPU 2, so then the CPU 1 will send a data to the shared memory through the buses, and after that the CPU 2 is able to access that data through the common bus. So in this way, one CPU is able to communicate with the other CPU. And coming to the multiprocessor is a single computer. Multiprocessor is a single computer that has multiple processors. It is possible that the process in the multiprocessor system can communicate and cooperate at various levels of solving a given problem. Because here in the multiprocessor system, the task will be shared by all the different multiple processors, so that the task can be completed in a less time, and it can be also completed in an efficient manner. Okay, so the communications between the CPU processors takes place by sending the messages to from one processor to another by sharing a common memory. So one processor can communicate with another processor by sending a messages to the other processor, or by sharing a a common memory. That is nothing but shared memory. Here, the term processor. So in a multiprocessor, we are using a processor term. So what do you mean by the processor? So processor here, we can use either the central processing unit, CPU, or the IO processor. So the central processing unit, it will takes care of the all the operations performed. And the IO processor, it will takes care of the operations which are performed on the IO devices. Like we are connecting several IO devices with the CPU, so that the operations performed, the operations are related to the IO devices, nothing but input. So sometimes we will read the data from the input device. Similarly, we can also send the data to the output device. So reading the data from the input device and sending the data to the output device. So these are the two operations that are performed with IO devices. So that operations are performed by the IO processor. As it is most commonly defined, the multiprocess system implies the existence of the multiple CPUs. Multiprocessors are classified as multiple instruction stream and multiple data stream systems. So these multiprocess systems are classified as the MISD systems. MISD means multiple instruction stream and multiple data stream. So that means it is having multiple process and the multiple memories. Okay. So the benefit derived from the multiprocessor organization is improved systems performance. So the use of the using the multiprocessor systems are, we can improve the systems performance. So how we can improve the system performance? For that we have two ways. The first way is multiple independent jobs can be made to operate parallel. So multiple independent jobs. So independent jobs, all that are made to operate in parallel, so that the tasks, all that jobs will be completed in a less span of time. So that is a one way. The another way is a single job, a single large job. It will be splitted into or partitioned into the multiple parallel tasks. So enter the task, enter a big task, it will be divided into multiple subtasks, so that the multiple subtasks will be shared by different processors like P1, P2, processor 3, processor 4. So that what will happen? The task can be completed in a less span of time, so that the computer systems performance will be improved. And come to the let's have a glance on the emergence of multiprocessing systems. So the main reason for emerging of the multiprocessor systems nowadays is because of the two reasons. One is the emergence of multiprocessors, and another reason is the emergence of VLSI technology. So because of these two reasons, the need of the multiprocessor systems increases. So the first one is the emergence of microprocessor leads to the concept of multiprocessing systems, as multiprocess takes very little physical space and inexpensive. So nowadays we are using multiprocess system. So in multiprocess system we are using multiple CPUs. So even we are using multiple CPUs, the physical space of the system will be small because of this emergence of microprocessor. Because the microprocessors are available in, they occupy very small physical area, physical space, and also they are inexpensive. Okay, so that is one of the reason, and another reason is the emergence of VLSI technology. So because of this VLSI technology, we are able to manufacture the processors so that they can occupy very lesser space, and also they consume very small power, and also inexpensive. So this using this VLSI technology, VLSI means a very large scale integration technology. So using this technology, it is able to reduce the cost of the processor and also improve the performance. Okay. So coming to the classification of the multiprocessors. So the multiprocessors are classified based on the memory associated with them. So we have classified into two types. One is a tightly coupled multiprocessor, and second one is a loosely coupled multiprocessor. So these are the two types of the multiprocessor classification. So first one is the multiprocessor systems with common shared memory is called tightly coupled multiprocessors. So the multiprocessor with common shared memory, so that are called tightly coupled multiprocessor. Whereas in loosely coupled multiprocessor, each processor element having its own local memory along with the cache memory. So in tightly coupled multiprocessor, they are having a shared memory, and that shared memory will be shared by all the different CPUs available in the system. But whereas in loosely coupled multiprocessor system, every processor it is having the corresponding memory. So every processor is associated with the corresponding memory. So that is the main difference between them. And the second difference is the information can be shared among the CPUs by placing it in shared memory. Okay, so already just before we have seen the multiprocessor configuration. So in multiprocessor configuration, we have multiple processors. Let us assume some 3 CPUs are there. CPU 1, CPU 2, CPU 3. So what they will do, so all these CPUs, they are using a single memory that is called shared memory. Suppose if they wants to communicate one CPU with another CPU, they have to keep the information in the memory. Okay, so the information can be shared among the CPUs by placing it in shared memory. So suppose if the CPU 1 wants to communicate with the CPU 2, so CPU 1, its information will be placed in the memory, and after that the CPU 2 can be receive the data after a time, after some time. So that in this way the CPU 1 will be communicated with the CPU 2. So in the loosely coupled multiprocessor, the information is transferred from one processor to the another processor using message passing system. So like packets. So the information will be transferred from one processor to the another processor in the form of information packets. So information is passed as packets. So that is through the message passing system. Okay, so this is a second difference. And coming to the next difference, that is the tightly coupled multiprocessors, also known as shared memory, because in the tightly coupled multiprocessors, they are sharing a common memory. So that common memory is called shared memory. Whereas the loosely coupled multiprocessor systems is also known as distributed memory. Distributed means we are able to differentiate. Okay, so distributed memory. So that means we have distributed means which are separable. So that means here every processor it is associated with corresponding memory. So that's why it is called distributed memory. So distributed means which can be separable, that are called distributed. So the memory which can be separable, that are called distributed memory. And the next difference is the tightly coupled systems are physically smaller because here in this type of systems we are using only a single memory. Okay, so that's why this type of systems are physically smaller, whereas the loosely coupled systems are physically larger, because here in this type of systems the number of process and the number of memory devices are more. So that's why physically they are larger. So the tightly coupled multiprocessors are more expensive and these are less expensive. And coming to the next difference, that is a overhead. Overhead for the data exchange is lower comparatively. So overhead. So the communication overhead. So overhead means the amount of time required to communicate one processor with the another processor. So here, because see here, so here in this tightly coupled multiprocessor, all that different multiple CPUs are communicated through a single memory. Okay, single memory. So that's why their communication will become easy. So here the communication overhead will be lower. Suppose if the multiple memories are there, then it will be difficult to communicate because it takes more time to communicate with one processor with another processor. Here in the tightly coupled multiprocessor, that problem is not there. So the communication overhead is very lower. Whereas whereas loosely coupled multiprocessor, the communication overhead for data exchange is higher when you comparatively. And the last one is a example of the tightly coupled multiprocessor. So two CPU chips on the same PCB board are connected by wires etched onto the board. So that are the example of the tightly coupled multiprocessor. So tightly coupled multiprocessor example is a two CPUs. We have a two CPUs and the two CPUs are connected through a wires that are mounted on the same board. So that is an example of the tightly coupled multiprocessor. Whereas in loosely coupled multiprocessor, so two computers are connected by a modem over the telephone system. Okay, so these are the differences between the tightly coupled multiprocessors and loosely coupled multiprocessors. And coming to the advantages of the multiprocessor systems. So we have a more number of advantages when you compare the multiprocessor systems with the single processor systems. So we will see some of the advantages. So first one is it is more reliable systems. More reliable systems. So in a multiprocessor system, even if one processor fails, the system will not halt. So this ability to continue working despite hardware failures is known as graceful degradation. So in a multiprocessor system, as we know, multiple CPUs are there. Even if one CPU fails, then the other CPUs will fulfill the task of the failed CPUs, so that finally the entire system it will run without halt. Okay. So for example, if there are 5 processors in a multiprocessor system and one of them fails, so suppose if one processor fails, then the entire system will run with the remaining 4 processors. So still with the remaining 4 processors, the system will continue to work. Okay. So the system only becomes slower and doesn't ground to halt. Okay. So out of the 5 processors, if one processor fails, then still that system will be run. So, but because of this one processor failure, the system's performance a little bit may reduce, but finally the overall system will run. And also it is more reliable. That means these multiprocessor systems, it can be we can use it for a longer duration. It can be used for several years when you compare with the single processor system. Suppose if you consider a single processor system, suppose if the CPU fails to work, then we cannot use that system. Okay, so that's why the multiprocessor systems are more reliable systems when you compare with the single processor systems. And the second advantage is improved system performance. Improved system performance. So, in a multiprocessor system, the performance of the system will be improved in a two ways. The first way is by multiple independent jobs can be made to run or operate parallelly. So we have a multiple independent jobs. So all that multiple independent jobs are allocating to the multiple CPUs available, so that the task can be completed in a less span of time, and also it can be completed in a efficient manner. And the second way of the improving the system performance is a single large job can be partitioned into a multiple parallel tasks. So by using these two ways, then the performance of the system can be improved. And coming to the third advantage, that is a more economic systems. So multi-process systems are cheaper than single process systems in the long run, because they share the data storage, peripheral devices, power supplies, clock, etc. If there are multiple processes that share data, it is better to schedule them on multi-process systems with shared data than have different computer systems with multiple copies of data. So it is more economic in a long run. So the multi-process systems are more advantageous than the single processor systems. And coming to the characteristics of the multiprocessors, so the multiprocess system is an interconnection of two or more CPUs with the memory and input-output equipment. And second characteristic is the term processor in multiprocessor. It can mean either a central processing unit or the IO processor. And third one, multiprocessors are classified as the multiple instruction stream and multiple data stream (MISD) systems. And multiprocessing, it improves the reliability of the system. And the benefit derived from the multiprocessor organization is an improved system performance. So just before we have seen how we can improve the performance of the system. So in two ways we can improve the performance. One is by operating the multiple independent jobs parallelly, and the second way is the partitioning a single large job into the multiple parallel tasks. And the sixth one is the similarity and the distinction between multiprocessor and multiprocessor. The similarity is they both support concurrent operations. Both support concurrent operations. And distinction is the network consists of several autonomous computers that may or may not communicate with each other. And a multiprocessor system is controlled by one operating system. So in multi-processor system, we have a multiple processor, but all that multiple CPUs are controlled by a single operating system that provides interaction between processors, and all components of the system cooperate in the solution of a problem. And seventh one is multiprocessing can improve performance by decomposing a program into parallel execution tasks. The user can explicitly declare that certain tasks of the program be executed in parallel. This must be done prior to loading the program by specifying the parallel executable segments. The other is to provide a compiler with a multiprocessor software that can automatically detect parallelism in a user's program. And the last one is the multiprocessors are classified by the way their memory is organized. So based on the memory organized, the multiprocessor systems are classified into two types. One is a tightly coupled multiprocessor, and the second one is a loosely coupled multiprocessor. So just before we have seen their differences. So tightly coupled multiprocessor means the multiple CPUs are using a single common memory. So that is called tightly coupled multiprocessor. Whereas the loosely coupled multiprocessor. So in a loosely coupled multiprocessor, every processor is associated with the corresponding memory. So that means separate memories we are using. So that's why it is called distributed memory or loosely coupled systems. So in this lecture, we have discussed about what is a multiprocessor and the classification of the multiprocessors based on the memory. So we have classified into two types: tightly coupled multiprocessors and loosely coupled multiprocessors. And also we have seen their differences. And finally, we have seen the characteristics of the multiprocessors. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.